the 2D array, that is the definition of the 2D array. So first of all, consider this is the 2D array. So this is the compile time initialization of 2D array, how it is represented. So first of all, the data type of the 2D array, the name of the 2D array, here I have given the name as A. Then the two subscripts, you can see here there is one subscript and you can see here there is a second subscript. So that is the reason it is called as 2D array, because it is having two dimension, two sizes. So what is this first subscript as? The first subscript represents how many number of rows you want in your 2D array, that is this one. And the second subscript, what does it represent? It represents how many number of columns you want when you want to create a 2D array. So this is number of rows, this is number of column in the two subscripts, and these are the values. These are the values which I am initializing at the compile time. So therefore 2 rows and 4 columns have given the values of all these elements. So the basic thing about the array, whether it is an 1D array or 2D array, this is a 2D array. So these array, first of all, here elements will be of the data type integer and they are placed one after the other in contiguous memory location. So that we have already seen in the 1D array and in couple of sessions which I have covered prior to this session. So as I told you, the first subscript represent number of rows, second subscript represent number of columns. So therefore it will be represented in this manner. So 2 rows and 4 columns. So these are the elements. So 2 rows. So for 2 rows and 4 columns, it will be like that: 1, 2, 3, 4, 5, 6, 7 and 8. So these are the elements you can see. So as I told you, first subscript represents number of rows, that is 2 rows. So you can see here, this one is the rows. That is, this is the one row and this is the second row, right? And 4 columns. So therefore this one is the column. First column, second column, third column and the fourth column. And this complete is one row, that is this one, 1, 2, 3, 4, this is one row and this is the second row. So you can see here 2D array. So that is the thing represented. How many number of bytes this 2D array will be occupying? So therefore size to be by 2 into 4, that is row into column into size of the data type of the elements. So here first of all, the data type, these elements are of the data type integer and therefore we know that integer occupies 4 bytes, right? So therefore we will multiply it by 4. This is 4 bytes. So what will be the answer? So 2 into 4 into 4, that is 32 bytes. So overall this 2D array will take so much of the space in the memory, that is 32 bytes. In case of the 2D array, that is having 2 rows, 1 row and 2 row and 4 columns. So if you consider this one, that is the first row. So if I do like this, so what you can see here, one dimensional array, and this second row you can see this is also the one dimensional array. So these two elements you are having in your 2-dimensional array. This is your first element, this is your second element. The first element is the 1D array and the second element also is the 1D array. So what is the definition of 1D array we have seen? In case of the 1D array, first of all, we are having an array of the elements. So if we are giving the integer array, that is 1D array we are creating, in that case all the elements will be of the data type integer. So here in case of the 2D array, it is collection of the 2 elements. So here you can see the first element itself is 1D array and the second element itself is a 1D array. Simply by this dimension you can understand actually how many number of elements this 2D array is having. It is having 2 number of elements, that is 1 and 2, and each element is an array of 4 integer, that you can find by number of columns, that is 4. So now if you represent this 2D array in the matrix form, so this is compile time initialization of the 2D array. Since I told you this 2 represent number of rows, 4 represent number of columns, right? So therefore you can see 2 rows and 4 columns. Now if you see this 2D array, as I told, it is a matrix representation. It is in the matrix form. So we know that indexing of the array starts from 0 to n-1. So therefore this is a row. So this is having the index 0. This row is having, and this row is having index 1. And the columns, that is 0 to n-1. So this is the 0 column, this is 1 column, this is 2 column, and this is 3 column. Now how these elements are presented in the memory? First of all, we know array elements are presented in contiguous memory location, one after the other in consecutive manner. So therefore you can see here this is 1. Suppose this is present at the address 200. First of all, address in the memory, they are in hexadecimal form, but for simplicity I am taking this number. So suppose this is your address wherein your 0th element of the array, the value 1, this is placed at the address 200. So the next element, that is 2. So it is placed at the location 204 after 200. So why the spacing of 4 bytes? Because integer occupies 4 bytes. So the next element, that is 3, it is placed at 208. Next element 4, it is placed at 212. Next element, that is 5, it is placed at 216. Next element 6, it is located at 220, and this is 7 is 224, and last element is placed at 228. So after 4 bytes, these elements are placed. So row wise it is filled. So 0th row is filled first, and then the next row is filled. So there are total 2 rows. Logical representation of the 2D array. It is in the matrix form. So we will also see the actual representation of this 2D array in the memory. So in the memory, first of all, it will be not present in the matrix form. It will be present in the linear form, because we know that memory is a long tape of the bytes. So that we will see. We will see how to calculate the address of the element by row major order wise as well as by column major order wise. So here one thing to add, that since we know that in 2D array we are having 2 subscript. The first subscript is for number of rows, second subscript is for number of columns. So first of all, you are initializing at this line itself. So in this case, if you don't give this size of the first subscript, that is number of rows. So this, whether this will work or not, yes, this will work, because you are mentioning the column and you are initializing it with the value. So it will understand how many rows will be there. But if you give here the row and if you don't give the column, so whether this will work or not, no, it will not work. So you will get an error. So you understand that it is mandatory to mention your at least the size of the column as well as at the time when you are initializing it. So even if you don't mention the row at the time of initialization, that will work, but you have to ensure that you give the size of the column when you are initializing the 2D array. So this is one point with respect to 2D array. So also, since you can see here, these are the values which we have initialized. So for simplicity, how we can also write it actually, so that it will be easy to understand. So here like this, since we know this 2D array, it is first of all the array of 2 elements, and each element is the array of 4 integers, like that. So you can also give it like that, 1, 2, 3, 4, and then 5, 6, 7, 8. Yes. So you can also give in this format. You can see here 2 rows, and 4. Each row is an array of 4 integers. So that there is total 4 columns. So this is how you can also initialize in this manner also. Easy to understand depending upon the dimension. So this is your compile time initialization of the 2D array, wherein whenever you are giving the size of the 2D array, that time itself you are giving the values of the elements, and therefore the name is compile time initialization, and it is represented in matrix form in this manner. And how it is stored? It is stored in contiguous memory location. So row wise the elements will be filled. So therefore you can see here row wise if we fill, so 1, 2, 3, 4. So this is 0th row is filled, then the next row is filled, the next elements with 5, 6, 7 and 8. We will be seeing the runtime initialization of the 2D array, and then later on we will see how to calculate the address of each element by row major order form as well as column major order. We will draw the formula for each of them, and we will also see starting from the index 0, and we will also change the index. So let's see first the runtime initialization of the 2D array. The simple program in which you are runtime initializing your 2D array using the subscript. So first of all, this is your main function, you can see. So the first line wherein I'm declaring my 2D array, because I'm not initializing, because I have to do the runtime initialization. I have to ask the user to enter the inputs on the console, and that I will be filling in this 2D array. So therefore the name is runtime initialization. So why I'm taking the two for loops, you can see one for loop is there, inside that one more for loop is there. Since now the dimensions are 2D, that is one dimension is for the rows and the second dimension is for the columns, and therefore for each row I'm taking this for loop, and in this for loop is for to traverse for each of the columns. So the outer for loop is for the rows. So for the 0th row, first of all we will be filling the columns, and therefore I have taken this inner for loop. You can see in j is equal to 0, j less than 4, that is column size, and j plus plus. And what I am doing here in this column, in this for loop, I am asking the user to enter the element, that is simply print. Scanf function is used to ask the user to give the input on the console. So we want user to give the input, so and user will give the value. So what I'm doing, I'm using this %d format specifier, since this is the integer value, comma, I'm giving address of a subscript I subscript j. I'm giving two dimensions and a. So what does it mean? It means that, so I is equal to 0, j in a for loop will complete its iteration one by one for 0, 1, 2 and 3. Once this iteration finishes, then I will be incremented, I will become 1, and again the inner for loop will start from again 0 to 4. So then for first iteration, for I is equal to 0, j is equal to 0, that is, so you are equal to 0. What happens, I told you in earlier diagram actually, that we are having in this format. What was the subscript? 0, like this. Like this, right? And this like this, A1, 0, A1, 1, and this is 3. So therefore row wise these elements will be filling. So we are at this. So at this address actually I want whatever user give the value, I want to fill it in the, I want to store it at the address of this. So I told you it will be like this. Suppose this is at address 200, so this will be at 204, this and 228. So you are asking user to give the input, whatever user give the input, you will store at this address, that is a subscript 0. Now next time what will happen, you have taken j is equal to 0, now j gets incremented. So j becomes 1, this condition is satisfied, and therefore it goes inside the for loop, and therefore it becomes as this, this is a of I. So I is 0 only, but j becomes 1. And again you ask the user to give the input and you will store at this address. So that is the reason you are giving address. Again j will be incremented, it will become 2. Again a is, now next time it will be like this, ampersand a 0 and subscript 2. At this you are collecting the value. Again j will get incremented, it will become 3. So then next time you will store the value at this location. So this, and then finally when j becomes 4, this condition is not satisfied, this inner for loop will not iterate, will come to the end, and now the I was initially 0, it becomes 1. Now again the same thing happens for I is equal to 1, same 0 to till 0, 1, 2, 3, these iteration will take place, and this is how your elements will be stored at the particular address in case of the 2D array. So this is why it is called as runtime initialization of the 2D array. So now we are done with compile time initialization of the 2D array as well as runtime initialization of the 2D array. Now we will be seeing how to calculate the address of each element, how these elements are actually presented in your memory. So first of all, these 2D array is not present in the matrix form. This is just a logical representation of your 2D array. Actually in the memory, because the memory is in the physical memory, it is what it is, first of all the long tape of the bytes in the one dimensional form. We are not having the same matrix in the matrix form, we are not having it stored in the memory. So how they are actually represented in the memory? So we will be seeing it by two ways. By row major order we will calculate the formula for same and we will see how it is stored, and by the column major order also we will draw the formula and we will see how they are represented in the memory in one dimensional form. So now we will be seeing the row major order representation of the 2D array. So here we will draw the formula in order to calculate the address of each element of the 2D array by the row major order form. As I told, there are two ways. By row major order, you can draw the formula, you will calculate the address of each element, as well as column major order. Also, you can calculate the address of each element of the 2D array. By default, your compiler use the row major order that we will be seeing here. So, first of all, as I told you, this is the logical representation of this 2D array. So you are given with this 2D array. This is a compile time initialization because we have initialized at a time of giving this size of the 2D array. So therefore you can see here. So this, if you logically represent in the matrix form, it will look like this. So as I told you that first row wise all the elements will be filled. So first row 0 will be filled. This is the 0 row and this is the 1 row because indexing starts from 0 to n minus 1. So from 0 row will be first filled first. So therefore 1, 2, 3, 4 you can see it's filled here, and then the rest of the elements will be filled in the row 1. Now this is just the logical representation, but how it is physically present in the memory? It is not present in the matrix form in the memory. In the memory it is present in the linear form. So this is the way it is present in the memory. So you can see first of all integer occupies 4 bytes. Therefore each elements will be placed at a distance of 4 bytes. So if your this one, that is in this 2D array, this is very zeroth element which comes first, that is this one. So if this is present at the memory address, that is 200. So normally the address is represented in hexadecimal form, but for simplicity I am giving this value. So suppose your this zeroth element of this 2D array is present at the address 200. So the next element will be present at 204, the next element will be present at 208, then 212 and so on. So you can see here how these 2 rows was there and 4 columns. So you can see here this 1 is present here, then 2, then 3, then 4. So row wise, 0th row, all the elements are located in the memory, and then the first row will be located one by one. The remaining one is 5, 6, 7, 8 that will be located. So you can see here this is your row 0, row 1. So first row 0 is filled in the memory, physical memory, then row 1 is filled. So therefore you can see in the physical memory they are not present in the 2D in the matrix form, they are present in the linear form in one dimensional itself. So since it's a row major order, therefore row wise they are located in the memory. So this we have seen the actual representation of the 2D array in the physical memory. Now we will see how to calculate the address of the element by using the row major order, how to draw the formula for the same. So suppose I have to calculate the address of this element, that is 7, and we are given with this index. So we are given this one. Here you can see first of all we should, whatever formula we draw, the result we should get as 224. So for that, what all inputs, what all things you are knowing now in order to calculate the address of the element 7. So first of all, you know that number of rows are 2 and the column is given as 4. I am representing for number of rows, that is 2, and C I am representing for number of column, and that is 4. And the next thing what I am given with, this is your I is equal to 1 and J is equal to 2. So I have to find the address of this element. So what all things I'm having R, C, I and J. Now let us see how to calculate the address of this element. So first of all, since it's a row major order, so you can understand by the name row major order. So what we will do, in order to reach to this element, that is 7, we will first of all see how many rows we have to cross in order to reach to this element, that is 7. Since it's a row major order, therefore we will check first how many rows we have to cross first. For this whole is your 1 row and this is your 2 row where the 7 is present. So to reach to the 7 only you have to cross all these whole first row. How you will determine that how much is the row you have to cross? Since I told you this I is 1, this is I, it's J. So by this first subscript, that is I, you will get to know that you have to cross only one row. So this is one thing. Now to reach to the 7, so if you are at this position and total you have calculated as I have got to cross one row. This one row is having total 4 elements in it, right? So how you will get this 4 elements? 4 elements is your number of columns which are present. So this one row is having how many elements, and these elements will be determined by simply, because these elements are simply the columns. So it will be determined by this value, that is 4, that is number of columns. So I multiply by, so this I am represented by the variable that is C. You can see here how I calculated. First of all, to reach to the 7, I have to cross this whole row, only one row. So therefore that 1 is given by this value, that is I, multiply by how many elements is present in this one row. 4 elements is present, that is 4 columns are there. So therefore I am multiplying this. So total we have crossed 4 elements till now. So how many more elements I need to cross in order to reach to 7? So you can see, first of all, to reach to the 7 we have to cross 1, 2, 3, 4, 5 and 6. So total we have crossed this whole 4 elements by this value. Now we have to cross more 2 elements, that is 1 and 2. So how to get this value, that is 2. So you can see here j is equal to 2. So just simply adding j. So j is 2, so that means 2 more elements you have to add in this value, and you will in that manner you will get total number of elements which you have to cross in order to reach to the element, that is 7. I got this formula. I have to simply multiply, so I have to calculate in number of the bytes. It takes 4 bytes in the memory since it's an integer. So simply I will multiply the whole expression into size of the array of the integers. Therefore data type will be 4. If it would have been the character, it would have been the byte would have been 1. Now the next thing is that now what I have to do finally, since I am having the base address of this 2D array, I have to add this expression with the base address in order to get the address of this element. And therefore, just a second, and therefore if I add the base address with this whole expression, so finally I will get the address as 2 to 4. So this is my formula in order to calculate the address of the element by using the row major order form. What it is? Base address plus I into, this is C, that is the column, that is 4, and plus J. We have seen J, this is I and J, this is what A1 and 2. If you are asked to calculate the address of the element A subscript 1, A subscript 2. So it can change actually. If you are asked to calculate the address of A subscript 1 and A subscript 3, in this your I and J value will be changing, but your R and C, number of rows and columns of the 2D array, that will be fixed because the size is fixed. That will not change, but I and J can change depending upon the address of which element you have to calculate. So here first of all you understood how to calculate the address of each element by using the row major order form. But if here you will be provided that your indexing you are considering to be starting from 0 to n-1. It can happen that the indexing is not starting from 0, it is starting from 1. That is, let me explain you for that what modification will be there if your indexing starts from not 0, it starts from 1 for the row as well as for the column. How the formula will get changed. So in case of the row major order, if the indexing starts from 1 and not from 0, so what change will be there in the formula that we will be seeing. So you can see here row 1, row 2, and for column 1, 2, 3, 4, it is starting with from 1, and for the column as well as for the row. Now we have to calculate, since the indexing have changed actually, therefore we have to calculate, suppose we have to calculate the same thing, that is the address of this element actually, that is 7, that is this one. So this is your I and this is your J, that is I is 2 and J is 3. And what is your row? Row is total 2 rows and column is total 4. Now you have to calculate the address. So since it's a row major, so therefore how many rows we have to cross, to reach to the 7 we have to cross only one row. So how you will get it? So first of all we are having we have to cross only one row, so your I is 2, so simply subtracting 1 actually from this 2 you will get 1, so you will understand, yes, you have to cross only one row. So this is this, and how many elements is present in this row? 4 elements is present, that is the 4 column, that is this value C. So therefore multiplication with C, and total 4 elements you have crossed. Now you are remaining with to cross more 2 elements in order to reach 7. So therefore how to get this 2 value? So simply I have to cross more 2 elements, so I will add so this 2 elements I have to cross. So therefore if I subtract j by 1 I will get answer as 2. So j minus 1 I will get answer as 2. So 2 elements more I have to cross. So then that I will multiply by size of data type. So here it, since it's an integer, it will be of 4 bytes, and total I will be adding the base address to it. So this is my total formula, the complete formula in order to calculate the address of the element, that is A subscript 2 subscript 3 in the 2D array using the row major order when the indexing starts from 1 to n. So this is how we have modified and we got this formula. Now let's see for also the column major order how to draw the formula, how to get the address of each element if you use the column major order. We will see for both starting from index 0 as well as we will be seeing starting from index 1. So this is very important interview perspective, because you will be giving these dimensions and you will be asked to find the address of the element by either row major order or the column major order. So for gate preparation as well as for the placement, this is very important topic. So let's see, and by default the compiler it uses the row major order, that is this one. So now let's see by the column major order form. So now this is, we will be drawing the formula to calculate the address of the element for using the column major order form. So how this is represented in the memory? So as I told you, this is a logical representation of the 2D array. So the matrix is not present in this form in the physical memory, it is present in one dimensional form. So in case when if it is a column major order representation of the 2D array elements, so this is how it will be stored in the memory. So since the name only you can understand it's a column major order, so column wise the elements will be stored in the memory. So you can see we have taken the 2D array, the same dimension I have taken 2 and 4, that is 2 row and 4 column. So and these are the values which I have initialized. Now you can see here this element 1 is there, then 2, 3, 4, 5, 6, 7 and 8, and indexing we are starting from 0 to n minus 1. We will see first for this, that since in the memory this is a column major order, therefore column wise this is 1 column, this is 2 column, this is 3 column, this is 4 column, this is 1 row and this is 2 row. So since it's a column major order, therefore the elements will be stored in the memory column wise, that is first this column will be stored, then this column will be stored, then this third column and then fourth column. So you can see here this column, that is this one, that is starting from index 0, so it will be 0th column, and therefore 0th column is having 1 first and then 5. So this is stored in this manner, and then the column 1 that is having 2 and 6, so you can see 2 and 6 is stored. Then column 2 is having 3 and 7, so 3 and 7 is stored, and the column 3 is having the element 4 and 8, so 4 and 8 are stored. So this is how they are stored in the column major order form in the memory in the one dimensional form, and it is not stored in the 2D form. So and you know that the address will be in the contiguous memory location 200, 204, 208, distance of 4 bytes since the elements data type is 4. Now coming to the point, now if you have to calculate the same address, that is address of this element, that is what subscript it is here, that is if you are asked to calculate the address of this one. So this particular 7 element is located at this index is 1 and 2, and you have to calculate the address of this element using the column major order when your indexing starts from 0 to n minus 1. So therefore we will just represent this this one as I and this one as j, and we know that this 2 and 4 we know the size of the 2D array. This is can represent as R, and we can use this as C. Now to reach to the element 7 using the column major order, we will traverse column wise. We will see how much columns we have to traverse. Earlier for the row major order, we have seen how many rows we have to traverse since it was a row major order. But since this is a column major order, so first we will see how many columns we have to cross in order to reach that element. So to reach to the element 7 that is to this element, we have to cross one column and we have to cross two columns. So 2 columns we have to cross, right? So therefore this value is given where actually this value 2, that is 2 column, it is given here by the value that is j, by the variable j. Now in each column how many rows are present? So this in each column total 2 elements are present, that is 2 rows are present. Each column is having how many elements, so that we can calculate total how many elements we have crossed till now. So therefore each column is having 2 element. You can see this one column is having 2 element, this one other column is having again 2 elements. So this 2 element is what actually it is the number of rows. So therefore that we can get by this R actually, that is 2 row. So therefore multiply by R. So this you got. Now you have crossed total these things, that is total 4 elements. But to reach to the 7 you have to cross this element also, so that you can reach to the 7. So therefore to reach to this actually you require what? So this is what you have to only cross one element. You have to add to this element only the value, that is one element more you have to cross. So you have to add, that is the reason I am using addition. And how I will get this one value? I will get this one value by this subscript, that is I, right? So I am getting it by this subscript, that is I. And now total number of bytes, because each element is occupying 4 bytes. So I will multiply it with the size of the data type integer. Now I will add this to the base address, because I am given with base address and I have to calculate the address of this element. So therefore this whole expression I will do addition with the base address. And this is how we have calculated the address of the element of the 2D array using the column major order when the indexing starts from 0 to n minus 1. We have also seen how they are represented in the memory in the linear form in the column major order. And it is in the contiguous memory because it is an array. Now we will be seeing how this formula gets modified if the indexing does not start from 0 but it starts from 1. So in case of the column major order, if your indexing starts from 1 and not from 0, you can see here the row 1, then row 2, then here for column also indexing is starting from 1. And see here I have to calculate the address of the element. I and j will change, but number of size will be the same actually for the row and column. So I have to calculate the address of this I, that is this is 2 and this is j. And I know that my total number of rows, that is the size of the array, is having 2 rows and column is having 4. Right? Now I have to calculate the address of this. Now in that case we have to, since it's a column major, we know that to reach to 7 we have to cross the columns actually. So total 2 columns we have to cross, right? So first of all you can see here to get the 2 column, that is how we will get this 2 value. So we are having j. If I subtract j by 1 I will get the value 2. So like this I will get j minus 1 will give me 2. So 2 columns I have to cross because j represents the column. And then how many elements are present in each column? So each column is having total 2 elements, it is total number of rows. So this column actually which is there, it is having total number of rows. So total number of row is how much actually that I will get by this, that will be multiplied by R. Yes, so we got total 4 elements we have crossed. So you can see here that is 2 column and each column is having total 2 rows in it. So therefore this much elements we have crossed, and we are supposed to cross one more element to reach to the 7. So one more element we require, so we should add that one more element. So that one value, how I will get? Simply I will be getting by this value. So if I'll subtract I by 1, I is 2, right? So if I'll subtract I by 1, I will get the value 1. So therefore I minus 1. I minus 1, I will get total one more element. So now I got how many elements I have crossed. Now I will simply multiply by size of data. And the whole expression I will add with the base address. So plus the whole expression will be added with the base address. In that manner I will get the address of this element in the column major order when the indexing starts from 1. You can see here. So this is how we have seen first of all in our complete session what is 2D array, the definition of the 2D array. We have seen how to initialize compile time, the 2D array, how to initialize runtime, the 2D array. Then we have also seen how this 2D array is represented actually physically in the memory, that is in the matrix. First of all, 2D arrays logically if we see it is in the form of matrix, but in actual representation, that is how physically they are represented, it is not in matrix, it is in linear form. We have seen two ways for that, by the row major order form in before this explanation, and in the column major order. And also we have seen how to calculate the address of each element by row major order form if the indexing starts from 0 to n minus 1. Also we have seen for if the indexing starts from 1 to n. The same thing we have seen for the column major order also, how to calculate the address of each element if the indexing starts from 0 to n minus 1 for column major order. Also we have seen how the formula gets changed if we have to calculate the address of each element if the indexing starts from 1 to n. So this is how we are done with this complete session of 2D array. In the next session we will be studying about the 2D array as well as the pointers. We will see how the pointers works well with the 2D array, how we will access the 2D array elements by the pointers. So let's meet in the next session. Till then.